In this lecture, I just want to give you an example about how things work in higher level programming languages, even though in the next module we are going to deeply talk about the C programming language, but in here I just want to talk how we could create a loop in languages like Python, which we were using as a calculator before. And again, this is not for you to understand Python, but is for you to just learn how things work in higher level languages. So I press Ctrl Shift and T to open another shell, and it enter the Python interpreter, and in here I just want to create a loop. So I say for x, I don't explain that how things work exactly, so I just say for x in range. I want to just you notice to the output and these kind of things. If I want to create the same thing as we were doing it using the assembly, so this was the program that we created in the assembly. If you want to do the same thing in Python, you say for x in range 1 or 0 and 10, and with the step of 1, I'm just telling that look at x as a variable between the 0 and 10, and just print this expression, print hello world. As x is 0, print hello world once, then x would be incremented by 1, it becomes 1. 1 is still smaller than 10, so we would have hello world printed. Then it would be 2. As you see, this is the step. Increment x by 1, it would be 2. 2 is smaller than 10, and so on. Now if we hit enter and again enter, you see that hello world is printed exactly 10 times, the same thing that we had in the assembly in here. What I want you to know in here is that well, higher level programming languages, since we said that computer doesn't know about these codes in here, should at last gets translated to this assembly code and then the machine code. And if I just open another shell and use the objdump as we said before, and just change the output to the Intel format and disassemble the chip printing program and hit enter, you could see the equivalent instructions in the binary format in hexadecimal representation in here to every instruction that we see in here. So higher level languages should eventually get translated to assembly code that we see in here, and then well, the machine could read the equivalent machine code. The assembler would translate them to the machine code in here, and the CPU would understand by looking at the ISR or instruction set architecture. And as we said, for example, when it sees some value like 75 and E0, it knows that it should look at the 0 flag, and if it is not set, it should jump to the address of 4000 B6, which is exactly this address. Again, for one more thing that we said we wanted to prove before, that printing is just a label, it's just an address for the beginning. In here, we explained in here that it would be the address of move RAX1. You see that move RAX1 is at 4000 B6, which would be a jump to that in this instruction in here. So if it is C, which should be compiled to the assembly. If it is Python, it should be interpreter or other kind of things. Every one of those things means a translation from a higher level language like this to the assembly like this. But well, you know that this is, for example, we could say that these for loops in here have been implemented by something like this that you see in here, or in other, if I want to show it using pseudocode, in mostly in other programming languages, it's like, for example, if you want to implement the same thing in here, you say I is equal to 0, I is smaller than 10, and then I plus plus, which means the same thing as in here or in here, that it says imagine I is equal to 0, and just do what we specify in here and do all of them, and then increment I by 1. As long as I is smaller than 10, I want you to do something. What we have done in here is that we created a variable, if you might like, R10. We inserted a value inside it, and we decremented it, and we said something should happen, some jump should happen as long as this value is bigger than 0 or is not 0. So as another, the last thing that I want to point out in here, let's say that what we have done in Python, we want to now say, for example, I want the hello world to be printed 5 times. We just increase the step in here. Instead of saying that I want the x to be incremented by 1 until it reaches the 10, I want to say that I want x to be incremented by 2 instead of 1. Now I hit enter and I see print hello world, and I hit enter again 2 times, and as you see we have hello world 5 times. Since x first would be 0, we would have 1 hello world, x would be 2, we would have another hello world, x would be 4, 4 is smaller than 10 still, we would have the third one, x would be 8, 8 is smaller than 10, and so on until it is not anymore. So, and we would just go break out of the loop. Now I want to implement the same thing in the assembly language, so it would be so easy. Instead of just decrement R10 by 1, which we said would be just equivalent to sub R10 and then 1, we would say sub R10 and 2. Sub is for subtraction, so we are just saying that subtract the R10 value, which is 10 by 2, and then save the result in the R10 variable, so in the R10 register. So I press Ctrl O to save it, hit enter, and then Ctrl X. Now I want to assemble it, so Nazem 64, keep printing.nazem, we create the object, and then we link it using the LD again, and we hit enter. Now if we run it and hit enter, you would see that we have hello world 5 times printed in here.